Congruent figures have all parts of one figure are congruent to the corresponding parts of another figure to be considered congruent. And the corresponding parts in congruent polygons, these are the corresponding parts that are the line segments and angles. It says write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So really, really important here, and this is something that gets forgotten so frequently. A congruent statement for these triangles is when you're naming the triangles congruent, and the order matters, and that's why it says the letter order is essential. If you don't name them in corresponding order, then the statement is incorrect. So you must put them in corresponding orders. And it's harder when they get to be like overlapping in the picture, and sometimes it's hard to visualize it, so you have to be very, very careful. Notice that angle A has the right angle. So in the other triangle, find the right angle. That means that, and you got to start with triangle here, triangle ABC, triangle. A was first, and F and A are corresponding because they have the right angle markings. The next letter in the statement was B. B has one arc on it. So find the angle with one arc, and that would be G. And then C has two arcs, and so does H. So those are in matching locations in this statement. Once you have this statement, you can use this congruent statement to answer the questions about things that are corresponding, like which angles correspond and which sides correspond, just looking at the statement. I prefer using the statement, and once I have it, I almost hardly ever look at the picture. And so that helps me remember what is the statement and how important it is and how valuable it can be. Angle A is the first letter, so over here, angle F. Now that we've got our statement, I'm just using the statement. B lines up with G, as long as we wrote it correctly, and C lines up with H. Sometimes they give you the statement, and that's when it's even better just to use the statement. AB is the first two letters. The first two letters over here is FG for the side there that matches it. BC, second two, GH, second two there. And then CA is last and then first, so H to F. And you could have said FH as well. On that one, the order of the naming of it, because they're segments. It's the same segment whether you name it, with F first and then H, or H and then F. So there, all they wanted us to do was to fill in those blanks with corresponding parts. Here it says use the diagram shown in which, and notice that they gave you the congruent statement, and I'm going to be using that to solve this problem. There's our congruent statement telling me what matches: angle F and angle S, angle G and angle T, angle H and angle U, angle J and angle V, FG and ST, GH and TU. That's how I wrote my answer to this identify all parts of the congruent corresponding parts here. And I set this up so I could just pull it out to the side and show you that answer quickly here. These are the corresponding parts in this picture, and I got that from this congruent statement. It says identify all pairs of congruent corresponding parts. These have 4 angles and 4 sides, so I've got 4 matching sets of angles and 4 matching sets of sides. Naming the sides, you've got to name them with their, the bar over the top and the congruent symbol in the middle there. Then find the value of x and the measure of angle G, so I'm going to do that part right now. So this right here, this expression is in angle G. G is the second letter. Over here, the second letter is T, and that means that it will match with angle T in this figure. So we can set those equal to each other. This picture didn't give you a lot of information to confuse you, but sometimes the pictures will give you information and try to throw you off the trail and make it harder for you to solve. This one, it was pretty clear. That was about the only choice we had. So to solve this, I'm going to add 7. 2x is 110. Divide by 2. We get 55 for x. And then they wanted us to also find the measure of angle G. Well, we already know that G and T are corresponding, so we don't even have to plug this in, but we could plug in 55 for X and solve it, or since I already knew what angle G was, it was 103 degrees. So those are the two parts of answers for that question that they wanted us to find. And then here's all the corresponding parts named. Right here we have the third angles theorem. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. And this comes from the fact that they all have to add to 180. So if A and B match and D and E match, then their sums are going to match. And when you subtract those sums from 180, you should get the same amount left for angle C and angle F. Then it said sketch a picture of an isosceles triangle. I've already sketched a picture here. Then label all the parts listed in the vocabulary here. So we have our sketch here labeled ABC. If we're going to say that this is an isosceles triangle, we should mark these sides congruent. In an isosceles triangle, these angles would be congruent. These sides are called the legs. So we've got a leg there and a leg here. And the top angle is called the vertex angle. And the bottom section is called the base. And these angles on the edge of the base here, formed by the base and a leg, are called the base angles. And so what I have in my blanks for the legs, I said that those are the two congruent sides, two congruent sides. And in this case, it's AB and AC, because they wanted us to identify it, label it, name it, talk about it here. The vertex angle is formed by the legs, and it is angle A. The base is the non-congruent side, and in this case it's BC. And the base angles are the two angles formed by the leg and the base, and those are angles B and angle C. If two sides of a triangle are congruent, then the angles opposite them are congruent. This is the isosceles triangles theorem, and you've already known this and been using this for a really long time. So if they give you the legs, then those base angles, angle B and angle C, are congruent to each other. The converse to that is if they give you the angles here, you can say that the legs across from them are congruent, and so in this case it would be AB and AC. So it depends on what you're given first, whether you're using the original theorem or the converse of that theorem. And we are going to use these in our proofs, and when I'm using it in a proof, I'll say the isosceles triangle theorem or the converse of that. Just remember, which one is which. The isosceles theorem, you are given the congruent sides. For the converse, you're given the angles. So just remember, sides are the original if you're given the sides, and if you're given the angles, that's the converse. At the bottom here, it says name two congruent angles. In this triangle, you know that FH is congruent to GH. So you're given those sides, you can name the congruent angles using that isosceles triangles theorem. And so they are angle F congruent to angle G. Pretty basic problem right there. The next thing says corollary to the isosceles triangle theorem says if a triangle is equilateral, then it is equiangular. We mentioned that several times when we learned about our if-then statements. The corollary to the converse of the isosceles triangle theorem says if a triangle is equiangular, then it is equilateral, just going forwards and backwards. Then we have two examples left in these notes, and this one here, I think it's missing some letters here at the bottom. I don't know what these are at the vertices, but I know that this is supposed to be X right here. And in this picture, there's overlapping triangles, and it's kind of hard to tell, but this one right here has all of its angles marked with that one arc, meaning that it is equilateral. So all of the sides are the same length. And then this one out here has these two angles marked congruent, and so it is an isosceles triangle with this piece congruent to this piece. So we know that x is the same as 2y, and we know that in that one that I had marked green on all the sides, that all the sides are congruent because all the angles are equal, and so all of these green side lengths will be 8, and that means that x is going to be 8. And since x is 8, then 2y is also 8, and dividing by 2, y is 4. So that gives us x and y there. But where that comes from is looking at these congruent angles, and particularly this one in the bottom left is weird. It's hard to see what's going on. It has a little double arc to match this one here in M, but it has this single arcing to match, this single arcs in these other corners. So you should be able to kind of see your equilateral triangle there with in the green that I have, and then the pink isosceles triangle. Then on the same page it has this one about quilting, and I have my answers written out, and I'll pull them from the sides in a moment, but just to look at the picture, and I know that your picture is very small, but on this picture, the main thing that we want on the picture are these triangles in the middle here. We're trying to explain why ADC is equilateral first, and then we're going to try to show these two triangles congruent to each other. And so in this picture, I have these isosceles markings on this triangle here, which mean that the base angles, which would be here at A and over here at C, would be congruent to each other, so I can add this marking here at C. What that marking is doing, because this one already had 1, so I have to mark this with 1 to match, shows me now that all 3 angles are equal to each other. And if all the 3 angles are equal to each other, then all the sides are equal to each other, and we just had seen that. If it's equiangular, then it's equilateral. So that is the part that we need to show this first part, why it's equilateral. But I want to talk, before I pull the answers out, I want to talk about the one on top. Now that we've marked all 3 sides with the matching markings, you can see that this triangle up top already had this marking here. And so it's isosceles as well, and it has this triangle mark or angle marking over here of 1 arc. So we're going to mark at B with 1 arc. Now we already knew, since all 3 of these arcs are the same, that each of these angles with 1 arc is 60 in this picture. That means also this one and this one. And since those are 60, 180 minus 60 leaves 60 left, which means that this angle would also be 60, and that means that it's equiangular and therefore equilateral, and then BC is congruent to it. So what we really have are 2 equilateral triangles, and since they share this side in the middle, that means that their sides are also the same length, and that would mean that they are also congruent. Because being equilateral doesn't necessarily mean congruent unless the sides are the same length. So here is this middle one for explaining that. Let me group these and I'll pull that to the side. So get that picture out of the way for now. Okay, so here's my explanation for why it's equilateral by the isosceles triangle theorem. Those 2 angles were congruent, therefore all the angles will be equal, so it will be equilateral. And then showing why they're congruent, since both triangles will be equilateral and have congruent side lengths, they'll have congruent corresponding measures and be congruent. And that is the notes for tomorrow.